Hello students, welcome to my Abhyas. My name is Sahana Kes and I am your physics educator. So we have studied in the last sessions about the physical world, like why is physics needed, what is the use of studying physics, right? And also we got to know what are the applications and also some of the fundamental forces in nature. And after that we dealt with units and measurements, which was a basic concept for building all the other physics topics, right? So today we'll be starting with the third chapter, and the third chapter is named as motion in a straight line. So nowadays you have heard about the 3D, right? So what is 3D? 3D is nothing but it is a three-dimensional, maybe like three-dimensional motion or three-dimensional picture, etc. But whenever you have to go to three-dimensional, first you have to study about the one-dimensional, like why the basics. You have to go through the basics, right? So similarly in this case what they have done is they have just given you the basic concept on how to develop for the advancement. Before that you have to study this basic concept, that is of one dimensional, and for that we call the chapter name as motion in a straight line. So motion in a straight line means what? Because whenever I consider a straight line is nothing but one direction, right? Whenever a body is going at only one direction, then we call it as a straight line. So whenever we draw a line, like this, then we call it as a straight line. So whenever we draw a line like this, we call it as a circular line or curved line, we call, right? So what is a straight line? Straight line is nothing but you are drawing a line from a point and it is exactly straight, that is it is exactly linear, you can say. Okay, so that type of motion we call it as motion in a straight line, or we call it as a rectilinear motion also sometimes. What we call it as rectilinear motion. Okay, so here why are we studying this? What is the need of this? Because to study about the aeroplanes, to study about the rockets, first you have to study about the buses, right? How the bus travels, like whether the frictional force is there, whether the air resistance is there, how is it, like when it is going straight, when the speed increases, when the speed decreases, what happens to it? Okay, what are the cases whenever the accident happens, what happens, like the brake fails, why is the brake failing there? Okay, so these all things you have to relate it to physics on itself. So whenever you relate it to physics, what happens? You have to study the basic concept, that is motion in a straight line. So before going to other motion in a straight line, we'll just look into what are the branches of this. Whenever we speak about motion in a straight line, what are the branches which are included in this type of topic? That is, whenever you consider motion. Okay, so what type of topics and what type of branches are considered? We'll just look into it. Okay, before that, we'll go to the chapter overview, like what will you study in this chapter, because it will be easy for you to understand, like stepwise to understand what all you will be studying. And maybe in your 9th standard and 8th standard, you have studied some basic concepts also, which will be again, we'll be studying it in brief here. Okay. Coming to the first thing, we'll be studying about the distance and displacement, the topic of distance and displacement, and then we'll be studying about the velocity and speed, and also average velocity and average speed, because both are different. And then we have instantaneous velocity and speed. These are also different. They are not the same. And then we have the acceleration, which is very important, and kinematic equations. So kinematic equations are very important. Like these are the basic. Okay, that is like you have the Newton's laws of motion, right? Similarly, these kinematic equations are the basic for all the whatever chapters you will be studying. Okay, in the future. Next, you have motion under gravity, and also you have the relative velocity. So in this one, derivation from the kinematic equation will be asked compulsorily. Okay, and also they will be asking you the definitions of basic, that is the distance, displacement, velocity, speed, etc. So if you have a very good idea with the examples, if you remember, then it will be easy for you to write down the definitions also. But remember, the derivation of kinematic equation, you have to study it because it is very necessary for you, and also it is very important, which is a marks gaining concept, you can say. Okay, so this is about the chapter overview. So moving on to the next, we'll just look into the chapters, like what are the branches whenever a motion is involved, that is motion of an object is involved, or motion of a rigid body is involved. So I just said you rigid body. What does this rigid body mean? What do you mean by rigid body? So we have rigid body. What do you mean by rigid bodies? So rigid body is nothing but it is a body with certain size and shape, and that size and shape won't be destroyed even after applying external forces. Okay, for example, take a stone. Okay, take a stone and press it with your hand. What happens? It doesn't break, right? And then take a huge stone and then apply some force, external force on it, but also it won't break, right? So what is happening? That stone is nothing but it is a rigid body. So what is a rigid body? A rigid body is a body which has certain size and shape which cannot be destroyed. The change, that is the size or shape, cannot be destroyed even after applying the external forces. Clear? So what happens whenever the rigid body are moved, or whenever we take motion in a rigid body, or whenever we consider the mechanics of the rigid body? So mechanics of the rigid body means you will be having two types of mechanics. One is when the rigid body is at rest. Okay, sorry. So when the rigid body is at rest, and another is when it is in motion. So at rest we are not concerned that much now, but in motion we are considering now. Okay, so whenever we consider the mechanics of rigid body, what happens? There are two branches. One is statics and another one is dynamics. What is statics? So statics is nothing but it is whenever the object is at rest, or you can say whenever the object is in equilibrium. So the motion of that, when we study the motion of that we call it as what? Statics. So the branch of physics which deals with the object whenever it is in equilibrium, we call that as, or that branch as, statics. So the name itself says, right, static. Static means what? The object is at rest or in equilibrium position. Usually we call it as equilibrium position. So whenever the object is at equilibrium position, the behavior of the object or the behavior of that rigid body, whenever we study about that, we take it as statics. And next comes, you have this dynamics. So what is this dynamics? So dynamics is nothing but it is exactly opposite to statics. So whenever the object is in motion, okay, whenever the object is in motion, we take the branch as dynamics. So the branch of physics or the branch of mechanics which deals with the study of object in motion is called as what? Dynamics. What about statics? It is the branch of physics which deals with the study of the object whenever the object is at equilibrium or rest. Whenever the object is at rest or equilibrium position. So now we are not much concerned about statics, so we'll be just moving on to dynamics. In dynamics, again there are two types of branches. Okay, so there are two types of branches, and those branches are nothing but one is you have the kinematics and another one is you have the kinetics. So remember the spelling, one is kinematics and another one is what? It is kinetics. What do you mean by kinematics? So any answers? Because kinematics and kinetics both are like, the pronunciation also is a bit similar, right? So what is kinematics? So kinematics is a branch of mechanics or it is a branch of dynamics which deals with the study of the object without taking the cause of motion. Okay, for example, whenever you take kinematics, okay, the cause of motion of the object is not considered. Okay, the cause of motion is not considered in the sense what? For example, what I'll do is, I'll take a box. Okay, I'll place it on a table. So once I place it on a table, I'll apply certain force. So once I apply certain force to that box, what happens? The box starts moving, right? So it starts moving, and as it starts moving, what I can say? It is in motion. That is, the box is in motion, right? Because it is moving because of the force, right? But I'm not considered about what type of force. Okay, whatever force I have applied, I'm not considering that. I'm just considering the motion of that box. Clear? So that is what we call it as the kinematics. Kinematics is nothing but it is the branch of physics which deals with the object in motion without considering the cause of motion. Okay, but this is exactly opposite. That is, kinetics is exactly opposite. So what does kinetics say? So kinetics say that as the object is moving, it is or it will be considering the cause of motion. That is, because of the force I have applied or because of the force which I have given, that is why what is happening? The motion is being caused. Okay, the motion is there. What is the kinetics? Kinetics is nothing but it considers. What does it do? It considers the cause of motion. The cause of motion. So that we call it as what? Kinetics. I hope you have understood this chart correctly. I'll just summarize you once again. So the first one is we have mechanics of rigid body. In that mechanics of rigid body, there are two branches. So first branch is we call it as statics and another one is dynamics. So what happens to statics? Statics is nothing but it is the branch of mechanics which deals with the study of the object whenever the object is at rest or in equilibrium position. Okay. For example, you can say that I am in equilibrium position now, but according to the earth, I am in motion. So that is how it is. So statics is nothing but the study of such things. Coming to the next, we have dynamics. So dynamics is nothing but it is the study of physics which deals with motion. Okay, that is object in motion. Coming to the dynamics, you have again two types. One is the kinematics and another one is kinetics. So in kinematics, what do? You have or you study or you don't consider the cause of motion there. Whenever the object is moving, that is whenever the object is in motion, you are not considering the cause behind that motion. But in kinetics, what you are doing? You are considering the cause of the motion of the object, right? So that is how it is. That is the branch of physics which deals or the branch of dynamics which deals or which does not consider the cause of motion is called as what? Kinematics. And the branch of dynamics which deals with the object in motion considering the cause of motion, we call it as what? Kinetics. I hope this is clear to you. So moving on to the next, we have a very important topic. Okay, before going to motion in a straight line, you have to understand straight line can be called in many terms, right? It can be called as translatory motion, it can be called as linear motion, it can be called as rectilinear motion also. So we'll just look into it. So coming to the first, we have the translatory motion. So translatory motion is also called as what? We can also take it as rectilinear motion. So what do we call it? We call it as rectilinear motion, or whenever the body is moving in a straight line, we call it as translatory or rectilinear motion. So what happens to this? What is the definition? So we'll just look into the definition. A rigid body is said to have translatory motion when it moves such that all the particles of the body, so all the particles of the body have the same direction of motion at all instants of time. So you can see the picture here. There is a boy who is riding the bicycle, right? So the bicycle, the man, that is the bicycle, the boy, the bag, even his glasses, everything is in one direction. That is, all the objects, all the particles are going in only one direction and at all the instants of time.